Alrighty then. We've had a bit of a break in the monsoon season here. It's actually not horrendously, horribly hot in the morning. I think it was 70 something degrees, 78 when I got up. It's probably close to that right now. Humidity's a little high, but that's because my backyard's got a lot of dew on the ground. And this is the wrap-up video, the too long didn't watch of building this DC generator. Basically, just going to go over some things that I learned from working on this, that if anyone else is going to build one, they probably want to watch out for. You know, where I got stuff, and you know, whatever I can remember. Anything else I'll put in captions on the video. So we'll start off with the motor, or the engine, depending on who you talk to. This came off of a weed eater that I got for free. It was an Echo GT1000. Company I used to work for, the owners had it and they couldn't get it to work, and it just needed the carburetor adjusted. Used it for years, and then I had problems with it, which when I put it back on the bench seemed to go away. It starts just fine. Mostly it's very difficult to start by pull starting because there's no primer pump. You have to put the choke on, which sucks gas out of the tank, and that's what, you know, gets everything going. Without the choke, you can't start this on a cold morning. The motor is a 200 watt, 24 volt, 8 amp wheelchair motor. It's a DC motor, permanent magnet. Came out of my mother's Jazzy something or another. When she passed away, we couldn't sell it or even give it away, so I just took it apart and took motors. Everything else is built. One thing I will say is that originally I was going to use special couplers that cost almost $30. You don't do that. Just get these cheap $2 or $3 couplers from China. They work fine. There is a little bit of a vibration issue, which would be near impossible to get rid of without machining parts of my own. And then, of course, the whole video on building this. I will put up something that has the total cost of building this, minus, you know, any parts you can get for free. If you were to build this and buy the parts, this would not be economical to do. It wouldn't even be, there'd be no point in it. The motors, you know, they cost anywhere from $150 to $300. And a weed eater, you can get one for $65. But if you buy the motor, weirdly enough, they cost a whole lot more. So what we're going to do is I'm going to pause it for a second because I forgot some stuff. One of the things that I wanted to go over is if you build something like this and you get the charge controller that I got, the one that you get off eBay, looks like this. There's one thing about this. Even though this is rated at 30 amps, as this sits, it can only handle about 1 or 2. The reason is this. These traces are too small. In order to for this thing to handle higher amperage, one of the things you're going to have to do is build this up with solder or maybe put a heavy-duty wire across here. Whatever you do, it probably cannot handle 30 amps. I would say you can safely use 10 to 15 amps out of this. As it sits, 1 or 2. So let's get this thing started up. I think we're out of gas. Stand by. Let it warm up before I can hook it up to a load. right, well, so that's it. I mean, it works. Will I ever actually use it? I don't know. Probably not. More than likely I'll use this for something. But this was mostly a proof of concept, or just a, you know, doing it because I can. So you can see that it was able to handle a 100-watt load. The inverter can handle 150 watts, although I had to give it quite a bit of throttle to do that. I had to keep the RPMs up. It was around 4,300 RPMs to do that. I don't know how that affects the motor, since the motor is rated at 3,700. Of course, I believe that's just the maximum RPMs at 24 volts with no load. The bearings can probably handle a lot more than that. I think it would probably fly apart at around 10,000, but anyways, so yeah, so I'm gonna leave it out here to cool off, and I'm gonna start working on my next project.